All right, good morning, everyone. This is our EIT prep on water resources and environmental engineering. I'm Jacob Mueller.
I'm Nick Cooley.
I'm Aaliyah Chavoya.
I'm Jacob Lothrop.
And I'm Andrew Tobia.
So what is our topic? Our topic, water resources, environmental engineering, covers a large scope, which covers 11 subsections in water. This will help us prep for the FE exam, so let's get started. We'll talk about the overview, which is starting with basic hydrology, basic hydraulics, pumps, water distribution systems, flood control, stormwater, collection systems, groundwater, water quality, testing and standards, and water and wastewater treatment. Basic hydrology basically covers the watersheds, infiltration, rainfall, runoff, among other things. There's also the equation Q equals CIA, which is most popular. And whenever you see on the FE Q is in inches or a curve number, you must use the NCRS method. Basic hydraulics, which includes the Manning equation, Bernoulli theorem, open channel flow, closed conduit flow, and Reynolds and Froude numbers are all included here on this slide. And now we'll transition into pumps.
For pumps, you'll again use the Bernoulli's equation in a pressurized system, and you're going to want to know what power you're going to actually need to move the water to a particular elevation. Next, another example problem, elevation head, one of the key parameters. And in this example, you can see a water distribution system where elevation is taken into account. And then for flood control, you're going to want to know how much pressure could potentially be behind a dam in case it were to rain. Do you need to use the spillway in order to avoid catastrophic failure? And for stormwater, things like detention time, the routing, and overall quality of that stormwater before it enters back into a system need to be addressed.
Next, we have collection systems. This involves both wastewater and stormwater, and that's just collecting this water and getting it from point A to point B. Next, we have groundwater. This includes underwater ground flow, as well as wells and drawdown. And then now moving more into the environmental engineering aspect, we have water quality, both ground and surface water quality. Then we have testing and standards for water, wastewater, air. And then finally, we have water and wastewater processing and the water treatment process. And this includes biological processes and softening and drinking water treatment.
Our goals are to know which equations are for specific problems, be familiar with wording, have general knowledge of the topics, and be confident to answer the questions in a timely manner, roughly 5 minutes or less, and overall pass the EIT exam. Our tentative schedule: if we start December 15th and end January 30th, it gives us about a month and a half. Study for about 3 hours each week. That is 7 weeks with 21 hours total. You do 1 to 2 topics per week. If you're more comfortable with the topics, do 2 topics, spending about 1.5 hours each. And if you're more uncomfortable, spend the full 3 hours that week on that specific topic. The resources we found: here are some textbooks. Professors you can contact are Professor Verbela, Professor Zink, Professor Yazdi, and then practice exams, they have them at Prep FE, and then the NCEES also has a practice exam.
Just some advice from somebody who's taking the exam. It's going to be really important to study a few hours per week and not cram till the last week or the day before. Some classes that you should keep your notes from and to look back on would be Civi 444 or any of these environmental engineering classes, 355, 556, or 558. Pace yourself and don't leave anything blank. It's all multiple choice, so just put something down. And if you've taken a class from any of these disciplines, then you'll be fine. Thank you for listening.